Good afternoon and welcome everyone to the ARPAS-UK CPD session with TEXO. We're delighted to have them here, and they are going to be talking about the adoption of drones in the oil and gas industry. We have James Arnott and Tian Wong here with us today, and we are delighted to have them here. Okay, I'm going to hand over to you, James and Tian. Okay.
Brilliant. Thank you very much. Hi, everyone. As Eleni said, we'll just do from TEXO DSI here. We'll just do some brief intros and then we'll dive straight in. I'm just going to share my screen. And hopefully everyone can see that. It's always perfect. So again, thank you for your time joining, guys. It's always a pleasure to kind of give one of these talks to people just to show what we're doing. By no means we're not the best of the best at it or the worst. It's just a snippet of what we're doing. There's some amazing companies out there doing some phenomenal stuff in the drone industry in this space and numerous others. So this is what we're pretty much going to cover off. Is just an intro to TEXO, drones in the oil and gas, picking the right tool for the right job, some of the key concepts of how drones have evolved in oil and gas and why. And then just some of the use cases that we've seen in this year, realistically, what we've been doing, and then looking at the future and kind of summarizing the key learnings and then a discussion, really. So an intro to me, I'm James Arnott. I'm now the Business Development Manager at TEXO. I've got a geological background, about 10 years experience in remote sensing. I've had multiple technical and operational lead roles before deciding to do the dirty and come into the commercial role more often. I've been with TEXO since day one. I was one of two people when it first started. We had a desk on the end of a load of other desks in the corner of an office somewhere. We've operated in multiple sectors since then, in the UK and internationally. So we cover oil and gas, nuclear, highways, rail, construction, you name it, we've worked in it or been some kind of iteration of it. The great thing about this job is I've kind of been here and delivered every kind of data that we've done. I've worked with 39 different UAS platforms. We currently have 26 live and 30 plus payloads in my career here, ranging from your Mavic Minis all the way up to some big heavy lifts out in South America and across the world. And that means I've worked with things like LiDAR, optical electrical payloads, hyper and multi-spec, thermal, gas detection, ground penetrating radar, ultrasonics and SLAM, and some really, really cool things in between that. I'm going to hand you over to my colleague Xiang, who'll briefly introduce himself as well.
Good afternoon, my name is Xiang. So during this presentation, James and I will be switching occasionally. Some parts he will elaborate, and then some parts I'll talk a bit longer. So my background's in oil and gas. I was in Aberdeen for 6 years, mainly in integrity management, and I was with Lloyd's Register, seconded to Maersk Oil, and towards the end I decided to join the drone sector about 7 years ago, and looking after the oil and gas side of things. Although I came from upstream and got involved in other sectors as well, a bit of downstream, maritime, and also some railway stuff as well. And over the years, I think I could say I take pride in help developing some methodologies and carrying out challenging jobs in very hazardous or difficult environment. And also, I suppose I can take pride in help train some of the inspectors and pilots along the way to be familiar in the oil and gas sector. Back to you, James.
No worries. So just a brief intro to TEXO. A lot of people know us for our drone services. We're actually a group. The division I work for, DSI, was the original. And since then, we've had 7 other companies in total. We cover everything from heavy engineering and fabrication, workspace solutions, asset integrity, which is traditional rope access services, my division, survey and inspection, port services, which this year serviced their 200th vessel they're proud of, recruitment services. They specialize in finding a lot of skill sets that have helped us out greatly in identifying key assets for the company in terms of pilots, processors, and our live stream division as well. So together, as it says, we're one. Most of our scopes of work that we work for tend to involve each other. We help each other out, we work collaboratively, and we've got some really incredibly bright people that I'm quite proud to work with in some of these divisions. And as I said earlier, we're not just one sector. So predominantly DSI, we were looking at this the other day, so I know the figure off the top of my head. There is no more than I think it's 18% of our work comes from one sector. So we're so far diversified that it keeps us kind of very busy and keeps every challenge different. So an introduction to drones in oil and gas. It's very hard to put a dot in the line and sand it, wherever you want to call it, where drones started in oil and gas. 2009, early noughties was the first kind of major stream adoption that we've seen of things like flare tip investigations. As the confidence grew with it, the services expanded. Basically, asset owners started seeing these things that weren't falling out the sky, having issues as the technology evolved, and giving them useful data. As always, oil and gas tends to be more cautious. They're not adverse to innovation. They just need to know that it can be done safely. Safety is paramount in oil and gas. There's no other key factor for a lot of them. Cost is in there, but if you can do something safer, keeping people out of harm's way, that'll always trump. So what we've looked at is safety hazards that we look at, hazardous areas, working at height, things that we do in HSE auditing. We look at the benefit in time. So how fast can we get these assets back online using drone technology? And we look at the cost. How much time is used putting scaffold up? How much time can we save personnel in working at height and things like that? So let Xiang explain this one here.
Yeah, I put this graph here as one of my favorite because it illustrates that in most of the assets that we will be working with or we have worked in the past, there is always some form of a maintenance program. I suppose for the duration of the life of the asset or the plant, you need to find a way to look after it. And over time, people use time-based inspection to risk-based inspection. And then even with that, it's not uncommon. It's not uncommon to see the maintenance side having their budget squeezed because they just most operators want to maximize their profit for obvious reasons. So where we fit in here is to be able to be in that optimal point where, do you spend a lot of money to inspect or to repair or to turn off the plant, or do you neglect it and then later do a lot of reactive maintenance and corrective maintenance, and God forbid, you might have some incidents that you might have to resolve that stop your plant from continuing operations. So one of the reasons I joined or joined this sector, this drone industry, is because having been in the integrity maintenance world, I can see a lot of benefits in using this technology. And in fact, it's almost as if you need to understand what are the many ways you can use this technology, which we'll be discussing later, to hit the sweet spot, so that you don't spend too much money. You don't always have to use the most fancy tools or most expensive technology, or you don't have to neglect it. You can always find a really good sweet spot, and this is where drone comes in many occasions. Back to you, James.
All right. So what do we mean by right tool for the job? You can see here, this is quite an old photo, actually. This is probably 2020, I want to say, when the Wingtras first started coming out. We were very keen on highlighting the right equipment for our clients and utilizing it to the best of its ability. The reason why is because the image you're seeing on the right is one of our guys actually for TEXO Integrity, and our job is to minimize the amount of time that John standing's on that ledge. We are the first point of call when they want to do the initial investigation. And that means we need to pick the right equipment. Some equipment doesn't handle certain environmental factors right. So realistically, we take this kind of holistic approach at looking what the job is, looking how it can be done, looking who's deploying it, looking at the skill sets. And all of that is done to minimize the image on the right as much as possible in a lot of the work we do in oil and gas. Jane?
So as James mentioned, there are a lot of, let's say, toys out there. You guys will be thinking, oh, you guys are drone guys, or you come with the fancy toys, etc. But they don't always meet the requirement for the job. Sometimes they need to cover a very wide area, up to 10 kilometers pipeline, for example. Then you can't just use a small drones. You need something bigger or fixed wing. And likewise, if you want to operate in confined spaces, you need to consider collision avoidance or the illumination in that spaces, and also GPS denied area. Fortunately, that kind of technology has come leaps and bounds, as you may know. We will touch on that later. So rather than going through, hey, look at all this, a catalog of tools, we need to first understand what you're trying to achieve here. And also, as most industry, as you're familiar as well, but very much so applicable to oil and gas, is there always a safer, cheaper, or faster way to achieve that? Always go through that exercise before you come to pick the right solution, if you like. And then if you do pick a solution, we always need to be aware of the limitations. Just because it is a fancy tool doesn't mean you can tick all the boxes. There's no silver bullet for any kinds of problem per se. Sometimes you need several robots, if you like, in some cases. Sometimes you can do 90% of the work using drones, but the 10% can be filled in by rope access. So that kind of solutions is not uncommon. And likewise, operationally, do we need to do during a shutdown? Do we need to change certain processes? Can you reduce the flaring? All that can be taken into consideration. In terms of skills, aptitude, experience, sorry, just before James, I'll just finish that part. I think we'll elaborate on that, but we'll have a discussion at the very end, because what I want to say on this is some of the exercises that people carry out in a low risk environment, and they might not be aware of other hazards that might be taking place on an offshore platform, for example, where there are multiple activities in a very tight spaces that you need to be aware of, so you are able to react accordingly. So sometimes if you are having a drone in the air, something happens, what do you do? What are your escape route? How do you turn it off? Do you ditch it? All of that comes into play in the oil and gas world. And then by doing that, you assess the risk, and then you come up with the mitigation action. And then lastly, all that is good, but do you come home or come back to the office with the kind of data that the client wants? The last thing you want is to have to say, to go back to the client and say, we didn't get what we want, we have to go back again. That would, in my own philosophy, defeat the purpose of using drones. So next slide. I'll briefly touch on 3 key concepts, which over the years I perceive to be most relevant to drone applications in oil and gas. And you're probably familiar with LARP, as low as reasonably practicable. Any solutions or any kind of action you take out there, can you carry out as in terms of the risk as low as reasonably practicable? If you say, for example, even doing drones per se, you do a tank job, you want to carry out multiple flights in a safe space. Is there a safer way of doing it? Do you need multiple batteries? Do you need to walk a long way to change your batteries? What about gas monitor? Things like that you need to take into consideration. Second slide, please. So hazardous area. So just to continue on the last point, there aren't, strictly speaking, the ones that are effective for the job, for inspection and surveying, are not ATEX from what we've seen so far. They are very, how do you say, niche ATEX drone out there that I've seen in the past, but they're probably not up to the job. For example, they might not have other functionality in terms of flight stabilization or the right camera resolution or collision avoidance. So it would be safe to assume that majority of the tools out there are non-ATEX rated. Why is it significant? And it's because in oil and gas, as you know, most of the places that you operate in have hydrocarbon and gases. So it would be good to familiarize, if you're new to this kind of sector, familiarize yourself in the differences in the zone 0, 1, 2, and in terms of the likelihood in terms of the period of exposure to hydrocarbon environment, explosive environment for that matter. And, and then how do you mitigate that? This is where, do you take a hot work permit or cold work permit? And how do you fulfill that is where we come into play in the drone world. Next slide, please. And CMOX is also another important one. And I see that most frequently in very busy areas. It can be onshore plant that has a shutdown going on, or in any given day offshore as well. This is applicable. The last thing you want is you were told that you're clear to operate in this area. You're halfway into your flight, and then suddenly there's a crane boom swinging over your head, which obstructs you, or they might be in your way in terms of your blue sky, if you like, of keeping your eyes on the drone. So this is something that can't emphasize enough. Really need to identify all the possible hazards up to the point where you launch it. So you can do your risk assessment on the desktop, you can do your toolbox talk, but up to the point when you're on site, sometimes when you're told one thing, something else may happen. So it's very important that people are aware of what other simultaneous operations that might be taking place.
It's definitely one of the key ones I've found in the offshore world.
Yeah.
New pilots not understanding what's decks below them or around them, high voltage switchgear. There's a lot of hazards in offshore.
Yeah.
I find offshore easier to fly than I do congested airspace, but the offshore, the hazards are there and some of them are hidden, and you really need to be doing a thorough investigation prior to your flights with all the key personnel to make sure you're negating this stuff.
We're showing a small picture there with the Helios drone inside a tank as well, because I have personally encountered an incident or near miss, if you like, where we were told that there was nothing going on inside a tank, and then turns out there were some yard workers doing a spool, dropping a spool, which actually contained fluid and sets off the gas alarm. Things like that can happen even though you were told in the morning that there's someone in there. So just always be very aware of your environment, as I would say.
I'll go to the next one. So now we're just going to touch on some of the use cases. So Zhang's going to start with some of the visual inspection stuff and just go in how it's evolved over the years a little bit from just pure visuals all the way through. And then I'm going to pick up on some other areas as well. And it wouldn't be a presentation about oil and gas without a flare in there.
I know this is probably a cliche now, because back in the day, you kind of call back 7 years ago, this is still something that you can push to operators and say, hey, we can inspect your flare when it's live. You can anticipate the problems beforehand, or whether or not you need to fix it, whether or not you need to replace it. And that was how it started, and we're going far beyond that now. So next slide, please. And there are many applications just with visual alone, and as you can see, the lists are not exhaustive here. You can use your visual inspection to do TAR or shutdown planning, and just to scope it out whether or not you have the space for the laydown area, if the defects are as severe as they think, and to review the work scope. There's numerous objectives you can hit there just with the pre-shutdown survey alone. The other one that is quite popular from experience is closing out planned maintenance backlogs, and this is applicable where the operator may have multiple assets out there, and they cannot access them or do not have the resources, and then they've reached a limit in terms of the deferrals, and then what do you do? How do you know the condition of those assets? And this is where drones may come in and say, look, we can deploy it, put it on the vessel, and hit them all at once. Likewise, the third item here, HSC targets, the HSC may come and carry out an audit and say, here's an improvement notice, you need to do this and this and this. Well, operators who are, budget strapped, they want to find a quick solution to understand the reality of what's going on out there and come out with a plan. And again, this is where drones can give you a really good visibility to understand the as-is condition, and also to share information with the other departments. A little bit of a repeat of an earlier point, NUI condition monitoring, but I would like to touch on here. You see the map on the right here is the Southern North Sea, where you have multiple offshore platforms. A lot of them are normally unmanned installations. And I believe this operator will have maybe 40 odd asset out there. Sometimes, you'll be asking yourself, how do you monitor the condition of all of these assets? So again, a good example is, you can have a dedicated service vessel, you put 2 men on the back of that vessel, and then you just, go around one installation after another over the 2 weeks, and you're able to achieve all of that and tick all the visual inspection boxes in a very short time. And the fifth one, helideck inspection, you may or may not know, but all the helidecks in the offshore are also certified. Again, this is what visual can do for you as well. Decommissioning, not too different from shutdown. You can actually use photogrammetry, which James will touch on later, to help with decommissioning in terms of creating the model, planning the lifting, loading access calculation as well. And again, next one, bird nesting survey, which is quite common for decommissioning as well. Prior to decom, the JNCC body will say you need to confirm that there are no bird nesting on your platform before you decom. So what do? Do you go on the boat with the binoculars, or do you send drones? Some people would argue that drones may disturb the bird themselves, but there are ways to do that in terms of doing it methodically, gradually reducing the distances, and knowing when to stop and what to look for. So it has been done, and it is something that has saved a lot of headache. And drops, also quite another common one for visual inspection, and this is applicable to shutdown, decom, and also operating platforms, site tours and site safety induction. The other one is you can use the images to help people familiarize. For example, a team of fabric maintenance painters, they want to estimate how much work they need to do in a given module. How long is it going to be? How much habitat you need to put out? What's the scale of scaffolding you need to bring out there? Having this kind of visibility can help, rather than having to send 2 or 3 estimators to come back with different estimates. You can use drones to be able to give you a straightforward answer. And yeah, we will touch on the LiDAR and digital twin, and James will give you some exciting examples.
So digital twins become a bit of a buzzword. Digital twin means many things. To me, it's a process. It's not just a 3D model. It's the information, how you utilize it about that asset, the live information you're feeding it. The digital models like you see here are often just the skeleton to help you visualize where that information pertains to. And a very good example here is, this is a JLA tower for one of our offshore clients. They wanted to understand the relationship of certain types of defects. So using the inspection imagery, we managed to produce photogrammetric models, which we then tagged up with the defects. And the client was looking at the severity of the defects observed and started noting a pattern in the way that the running blocks were causing corrosion and splitting in the wireline. And it's just things like that the human brain's very good at doing 3D visualization in points, but some of these assets where you've got 100 different things wrong, it's very hard for the brain to keep up with. How does this relate to that? So this is where we're using that digitization to help our clients. And it also gives them an incredible tool to start measuring up against. Once we add control in through traditional laser scanning or terrestrial total station control, we can really take something that goes beyond a pretty picture and give them good dimensional information. Visuals mean a lot of things to a lot of the offshore installation managers. As Zhang touched on, 3D tours are becoming a very big area. If you can walk around a rig before you step foot in it and understand the key hazard areas and you're familiar with them, perfect. Now, it's great with the ground-based. Things like the drones are now adding a new perspective, where in this one here, we've got a client in Norway who's able to navigate around their rig via the ground-based and the airborne seamlessly, understand their asset and start tagging information. I've recently got off a call with them. They've turned this into a virtual tour. The HSE guys have literally sat there as part of their induction and will walk you around that rig. So you'll sit there, do your video, you'll understand the key hazards. Now, the photogrammetry has become a very big talking point in recent years, and it's really advancing. Not just photogrammetry, NERFs, twins, things like that. This is one of the things that we found in offshore. We compete and work with a lot of companies who do terrestrial laser scanning. We do it ourselves. The image on the left is what you would get from a terrestrial scanner of this asset. Now, often because of the height from where you scan, the images can look a little bit washed out. You don't get full capture. And in things like decommissioning, the jackets or leg structures are the key areas these guys want information in, which you're often getting partial or incomplete. The image on the right is a mixture of laser scanning and photogrammetry. So we've retained the accuracy of the scans, but we've infilled all the little gaps using photogrammetry. That means bits like the back of the accommodation block here are now filled in, which there's a number of key vents, key pipelines on there. Bits like the lifeboat davits, we don't have all the information because we can't stand around, and we now do. Something as simple as the signage there creates quite a big block for some of the areas that we want to scan. So we're now using the drones to infill. The risers, the pipes that come out of the water, key areas for mapping. Now, we started with just doing visual inspection of these to look at corrosion, damages, fishing lines caught around them, things like that, all real world issues that you need to understand. We now use the drones to infill and generate these 3D models so they can start doing dimensional checks on them as well with the laser scanning. So when they come to decommissioning, they know what they've got there. Something as simple as a desktop-based exercise where someone can go in and see that asset and count how many risers are there, not rely on technical drawings or output feeds or go through hunting numerous packs of pin diagrams. It's really becoming interactive. And the final one, the jacket legs. From some of the scanning we do, we used to have spider decks. We don't have them on a lot of assets anymore, which these are the lowest deck. So being able to use drones to fly off and over the side and down gives us that great visual inspection tool. So we can see the underside of the asset. So we can see what general condition it is, and we can start infilling the gaps. It's leading to the question, should this be part of the surveyor's toolbox or the pilot? And we find it's both. Because what you're doing here is we're building up that dimensional survey picture, but in the process of taking hundreds, if not thousands of images of these assets, inspectors and people the like are going through it. I've had clients doing stock inventory, realizing they've got containers on assets that should be on another asset, or that they're looking at the general condition. I've had inspectors onshore spotting defects with their jacket legs from photogrammetry data that no one was aware of. So if you can start sharing this data, finding a centralized place from it, it becomes incredibly useful like this. So we've been undertaking digitization for a number of our clients in the UK, West Africa, Europe, things like that. And it's really helping taking these monumentally massive assets, decommissioning headaches, and putting it on their desktop for them. It's giving them the information in the areas they may not necessarily have had before. It's giving them engineering grade design tolerances because of the laser scanning implementation, total station and control, and the photogrammetry being used to infill rather than the be all and end all. It ties back to what we said earlier. It's the right tool for the right job. We send a two-man team off doing multiple scopes. And then we pair that with the surveying as well. So it really, really does come down to training the guys, getting the most out of the time you've got on board to deliver what the client needs. Now, most of what we've talked about so far is offshore. People forget that a lot of oil and gas work takes place onshore. In the UK, there's masses of infrastructure projects that you drive past every day, run under your feet, that people just aren't aware of. So this leads me on to LiDAR. So LiDAR in oil and gas has mostly been for onshore mapping, although SLAM tech's been used recently. We started doing SLAM technology in 2018, 2019, and it gave us a good point cloud. It gave us floor plans. We gave it to the engineers and they're like, I can't design off this. So for us, it created the basis of that digital twin, that good picture that we could get that all encompassing. It became phenomenal. What we moved on to was kind of the heavy grade LiDAR systems that we use, like the VUX ones. So you can see here, I like this video because it kind of shows you the granularity of detail. So we're flying at 70, 80 meters. We've flown up the line one side, crossed it and come back the other. Now, this is the level of detail you're seeing here. You can see the trunk diameters, how much of the ground, small ditches. Now, if I would say to you that the 20 kilometers of pipeline needed to be mapped to this detail, terrestrially, we would have given up. It would have been impossible. Now we can use a drone and clear the box out. You can see that whole pipeline route, the whole way for a new planned pipeline. That level of granularity has revolutionized how we're planning, how we're looking at things that go wrong. It's stopped massive budgetary expenditure where clients are running into things they're not sure of. So they've got this detailed picture of what's going on. It means things like river crossings where we're putting pipelines underneath them. We can scan the banks to see the profile. And then we compare that with bathymetry data from unmanned surface vessels. So we can see how far we're going to have to drill. It's really kind of changed the game there. Internal inspections are huge. There is some phenomenal players in this, some amazing work being done day in, day out by many different companies. And me, for one, I've had the pleasure of flying some of the most challenging environments I've ever flown in my life. Tunnels, pipelines, onshore, offshore, and this is the one that I always love doing. It gets, for me, the man or the person, sorry, out of that confined space. It's one of the biggest at-risk areas in any operation. And recently, someone I know, another company, put on a great article about why are we still sending people into these places. There's other alternatives. And yes, drones don't solve everything. And I'll give you a recent use case. We do a FPSO cargo tank inspection. Traditionally, it took 14 people 3 weeks to do the general sweep. We were delivering the whole inspection with 2 people from outside it in 2 days. And what that meant was that 80% of the tank, we could say, yeah, it's fine. And the 20% that the drone couldn't clean the surface on or couldn't get right up into somewhere, that we could then go back to them and go, right, here's the 20%. Their manned entry scope went from 3 weeks down to 4 days. The hundreds of man hours minimized exposing personnel to this hazard was phenomenal for them. I'll let you pass you over to Shang, who's just going to talk a bit more in depth about this stuff, what it's been used for.
In the context of the industry, how do you have confidence in terms of what you've done, with your drone actually covers the area that will meet any class or any guidelines, the requirement? So the class bodies, for example, we're talking Lloyd's Register, ABS, BV, DNV. They were quite good at picking this up over the years, and also quite receptive to it. Some of them even developed their own team to do that. So this is becoming the popular tool to carry out tank surveys, whether or not you need man entry, or ideally without the man entry. But in most instances, you still get a surveyor to walk around and have a look-see. But then, like James said, you can still do 80–90% using the drone. But over the years, along with the advancement of the technology, becoming more robust, more reliable, and also with people becoming more aware of what you can do, and also the confidence in the technology, and as well as the personnel that are operating it. This has come leaps and bounds over the last 5 years alone, to be honest, where you're seeing this kind of solution becoming widely adopted, be it in the maritime or in oil and gas. And likewise, in onshore, we just touched on briefly. We know the tank inspection programs that are under API 653 or EMEWA 159, which is the equivalent in Europe, have really recognized this as one of the solutions, not just with visual, but also with NDT. Now, the thing about the NDT is it's exciting, it's complicated, and we have to remember there's still limitations to that, because we're essentially trying to put a lot of components to make sure it gets to the point, the areas of interest, to take the readings and make sure the contact is correct, etc. And there are very few technologies out there, but they are out there, and the ones that were successful are being used repeatedly. So I just wanted to share this to help people be aware that this is not just pie in the sky kind of toy. It is actually being done, being recognized, and actually have helped sign off a lot of the maintenance program. Likewise, in the technology they use, a small stable robot that could go into GPS denied area can also be used to inspect in between pipe racks. If you suspect any corrosion under pipe support, where you see crevice corrosion, for example, areas that you have to put on wicks of scaffolding, you can resolve that in less than a week using drones to find these congested pipe bridges, congested areas.
Definitely.
Briefly touching on in the future, the the NDT part, I haven't seen anything that does crack detection. So far, it's only wall thickness checking, and even that alone has its own limitations. For example, if it's just a routine one, you may not need to have a clean, you might not need to do surface preparation, just like a sample point will do. But most of the time, people want to look at the remaining wall thickness in areas that are corroded. So how do you do that? There are drones out there that are fitted with a miniature grinding tool that can remove the scale down to, I don't know, don't quote me on that, but it's SD2 or equivalent kind of a surface roughness that should allow you to push the probe effectively to ascertain the remaining wall thickness. There's also a miniature version of EMAT that are available on the market now that you can fit onto the drones. The EMAT here is electromagnetic acoustic transducer, which essentially you can detect the remaining wall thickness. The physics of it is similar to eddy current, but it can penetrate through corrosion scales to give you the remaining wall thickness. Yet, it is still important to understand the limitations. Sometimes you tell you can penetrate up to 3 millimeters of scale. Then if you have a corroded area that has 4 millimeter scales, etc., you may want to use a different solution, for example. Okay, that's me.
No, it's definitely been one we've seen. I mean, we've run UT drones 3 years ago and just found the limitations far exceeded the benefit in some areas for us currently. And I think the tech will change dramatically in the next 5 years, and we'll start seeing this really becoming an active solution.
Yeah, then I suppose the golden goose, I suppose, is a drone solution that not only does UT but also carry out spot repair.
Yeah, that would be phenomenal.
Yeah, not
impossible, but yeah. But other forms of NDT do exist. Things like thermography we're using more and more as more and more people understand it. I recently used it onshore to look at refractory linings and condensator towers to see where they were failing. One of the things is it gives your inspection team another view, another dimension to their observations. It gives you things that you might not necessarily see visually. It gives you a great way of inferring things. And this is key to remember, is the competency of the person. We can all go out and buy a thermal camera. If you don't understand key things like transmissivity values, emissivity values, things like that, stuff you're looking at, you could interpret wrong. And some of the decisions we make in oil and gas are not done lightly, because it could mean putting someone at height, it could mean unforeseen cost, it could mean sending someone to repair something that may not necessarily be read right. And that's what I mean by the analysis trap. There's a great example I learned with 2 images side by side. One looks like a severe problem. The same one looks like you've taken it after you've repaired it. It's not. It's just this person has used a different color, or they've changed the palette. So that's how we need to be careful, and that's how we present the findings. Thermal is one of those, you never set yourself up and go, this is definitively it. It's always, this indicates this. And one of the things that thermal does suffer with is it's very environmental dependent. If you're looking, unless you've got severe heat changes, like on this exhaust stacks, a bit of wind will remove what you're trying to observe. So in the offshore sector, it's not always the best tool, but it can give you a lot of useful information if used right. The bottom image you can see there is an extremely corroded hull of a jackup. Now, using the thermal, we were able to identify which of those blisters had fluid retained with them, which has a direct implication on how long or how fast it's going to corrode in areas. So it meant that the client could understand which blisters were fairly new, which ones were old and had basically been lanced, and go for it that way. We use thermal in many applications: optical gas imaging, lagging and coating inspections, installation assessment, vessel assessments. We use it in emergency response, and that's not just for finding people that fall in the water. It's actually quite difficult to do that. We use it for things like fires. We use it for things like oil spill contamination. And again, we use it in things like flare inspection for looking at kind of parameters such as burn back. Now, these are all different types of camera, and I won't go into the technicalities of it, but you have long wave, short wave, things like that you need to account for. So simply getting your M300 out or a Mavic to try and take a thermal image of a flare tower, the camera's not designed for that kind of temperature. Something like the optical gas imaging camera would be, and that's where people need to understand the tech you're working, because you don't want to be going out and delivering something to a client, and all it takes is one person in that office with a bit of familiarity with thermal to start picking it apart. So if you're going to start using stuff like this, it's key that you understand the equipment and what you're doing. And there are some phenomenal training people out there to kind of help people through this. Gas sensing. Recently completed a lot for one of our clients on their rigs. Now, this has become, especially with the environment, a huge issue. And it's not just onshore and offshore, sorry, it's onshore gas pipelines, landfills, things like that. So we've worked with a number of systems over the years, qualitative and quantitative, like sniffer systems in the top right, optical gas imaging systems that we fly, bottom left, and tunable detector laser and spectroscopy systems. So essentially, these allow us to change the frequency of the laser to look at different gas types. I call it DAL, differential absorption laser, but tunables become the more popular version. I've used this before in my background in geology to detect methane leaks, looking for oil reserves in parts per billion. So this technology was from man. Now we've got it small enough to get on a drone. It's impressive. So what we're looking at generally is what we call fugitive gas detection. Platforms leak. There's no ifs, ands, or ways or buts about it, whether it's from the flare or incomplete burns, or whether it's from certain parts of the process. And they have a calculation for this. They know it's going to happen, so they have to justify it. What they want to do is make sure that there's no fugitive emissions happening that they're not aware of. So it boils back down to those hazardous areas and understanding. So to give you an idea of the concept, we take an FSU like this, we fly a dial system, and we can pinpoint higher leaks, higher concentrations, sorry, and that can generally track back to a leak. In emergency response, we touched on it before with the thermal. There's been a lot in offshore oil spill response recently, a lot larger drones generally. But we're seeing people push to have these on the back of their response vessels, small systems that they can start coordinating their boom deployments. They can use thermal views or ultraviolet to look at slicks, and they can understand the skimmer deployment. I'll let Shang talk in a bit more about the next three because they're a bit out of me.
Oh, no, I just wanted to touch on that. You may or may not be aware of the accident from the Didcot demolition power plant, where there were fatalities, and when that happened, when a demolition go wrong, how do you go and do a search and rescue? It's a very difficult and sensitive operation because it's human lives involved. Somebody's loved ones are in there, and yet you can't go in there immediately because you might lose more lives. So incidences like that, obviously, drone become the very obvious solution for this. And this is where a careful, highly skilled drone operator will be able to say, okay, here's a situation, where do we go in? How do we cover the area methodically? How do we look at the areas to help structural engineers to say that this area is okay for them to excavate gently, to go back inside, things like that. So this is an example, which a real life example where drone was used in terms of a recovery exercise. And then going forward, drones, you can have a drone team that is part of an emergency response team on a gas plant. I've seen this in the Middle East, newer team there as well, who are basically always on standby 24/7, and they have to be on site in half an hour's notice. But in order to work slickly and effectively with the emergency team on the ground, what they do is they have regular circuit breakers exercise to basically simulate an accident or incident, and then they will say, okay, this is what happened, this is what you do, etc. And this has been done, and drones do play a big part, and has become very popular in some parts of the world. And then likewise, next one is, if there's an incident, you may remember the Costa Concordia in Italy, a big cruise ship that tipped over, and they have to basically lift it up very carefully. And even during the lifting operation, they have to check, making sure all the cranes are functioning, rotating, effectively, so that none of them were overheat or none of them were snagging. Then you might undo the whole lifting operation. We're talking a really large cruise ship. You try to set it upright again. So again, this is where drones was used in that lifting. I'll pass back to you, James. You can talk about the salvage.
So I've got a smaller version.
Yeah.
I'm just conscious of the time, so I'm going to kind of get through these quite quickly for you guys so we can do some questions. Emergency response, salvage. So what you're looking at here is from a client of ours that we work with, a fishing vessel trapped in an ice floe. And this client needs to understand what was missing off the vessel, what had come off it, the angle it was, how they were going to refloat it. Big problem for them was they believed there was polar bears taking up nesting inside. So you literally had the rib craft there pushing on. As soon as we got the slightest hint of anything, we pushed off to get away. Didn't quite realize until they gave me I was briefed on it, how fast polar bears can run and swim, which is terrifying. So that's all the kind of uses you're seeing there, from the Costa Concordia down to small scale. We did toy with the idea of sending something like the Helios in for open hatches, but we didn't need to in the end. It was evaluated. Engineering and installations. I love this one. So this is one that we did as a group. We helped fabricate parts of this J-lay tower, and we used the team to go in. So we used traditional scanning and drones to build up photogrammetry models to enable engineering grade design work. So we were looking at here to make sure this was the perfect alignment for when it got lifted onto the ship. And then we use it for the drops, because unbelievably, a lot of stuff gets left on these things. As they get lifted up right onto the ship, it all comes raining down. There's some terrifying videos of what one of those bolts will do to a hard hat from 20 meters. And this tower is 30 to 40 meters in height. So you can see here, the gentleman holding the TEXO bag is Alan. He's our port services director. He is incredibly passionate man and a work of God with it. So this was installed out in Holland. So it got shipped from Port of Blyth, sorry, all the way out to Holland. Sleipnir vessel was brought in, the world's largest crane vessel, and TEXO were actually coordinating the lift with port services. So our job was to control the lift to make sure the vessel was perfectly aligned, that we had, I think it was 5 to 10 millimeter tolerances for this thing to be lifted into position. That meant through the whole lift that Alan was in charge of it, and what they would do is reballast the vessel, move it rather than the crane. So the first thing was that we were checking that the cables were sat right in the hooks, that they hadn't shifted. So live point, what we didn't want was to suddenly shift down and the whole thing move slightly. We were checking that the pins here were aligned as it came in. We had the drone eye level with it rather than a human being on a rope. This bit, we was having cameras set up to stream the pinholes, and then we were going to use, well, we were using Helios drones to fly in and have a look at stages. So this lift took about 9 hours in total, went through the night. And finally, it was used as an overarching picture. This was streaming live to the commanders in their command area from various different drone points, that they were having these images all feeding into them, showing them what was going on. That sort of leads me to kind of the future. And Shang, I'm probably going to bomb through these ones if that's all right, because we've got very little time to finish this one up. We look at the future, and this is no means exhaustive. There's some stuff going on out there that's not even on our radar. And we're looking at things like battery power, longer flight times, material sciences, airframes are getting lighter, they're getting stronger. We're seeing things like delivery payload systems ferrying stuff between ships to rigs and rigs to ships and key parts. We're looking at things like self-certifying systems. So our drone in the box solution needs to know it's okay to do what it's doing, not just the weather, but it is hardware. There's no pilot there to take it out, check your props, check your arms, do everything that we all do day to day. Advanced NDT, as Yang's alluded to earlier, is really coming on in leaps and bounds. And even the idea of UAS conducting tasks, painting, spraying, basic rudimentary stuff's now becoming a reality for some of our clients. And again, Moore's law, everything's either going to get better or it's going to halve in size, production, however it works. So we're looking at more robust flight systems for GPS denied. We're looking at better sensors for our payloads. I'm sure there's some of you on the call who've been in the drone industry for a number of years. And if you compare some of the sensors we use now to what we were using 10 years ago, drastic difference. I mean, from me and my background, we have hyperspectral sensors the size of, well, size of your fist. When I first started 10 years working with them, they were the size of washing machines. It's phenomenal. And things like real-time AI analysis, improved autonomous systems. We've seen it not just in data point of view, but flight, like Skydio. And again, the wider use of the drone in the box and the collaboration between them. We've all seen images like this. We've seen it become a reality for some of our clients working in South America, using drone in the box to monitor things. We're seeing things like Spot the Dog working, pairing up with a drone to enable it to reach further. These things walking around autonomously with drone solutions, talking to each other. And then we're seeing this centralized hub of information at the bottom left occurring. So for me, some of the other future applications, just talking on this, Shang put this one in, and I'm going to bomb through it very, very quickly. It's hyperspectral. I've worked with this systems for 10 years now. We used to use it off planes and satellites to identify hydrocarbon resources. Drones have got that good with them that we're now able to get sufficient data that not only identifies hydrocarbon spills on the surface, tells you what type. It's phenomenal. And we're looking at it for things like exploration geology, material classification, hazardous material, pollutant tracking, looking at pathways. The very early days of this was manned aviation or satellite, and there is so much more room for research in this area, especially with the deployment of drones. It's phenomenal. It's becoming more cost effective. The cost to retask a satellite compared to the cost for this stuff is worlds apart. Bringing in a manned aviation, and what we're looking at is areas of the world where you physically have to ship aircraft out to them to do this. Someone can fly out there with a drone and start doing some very impressive work. And I'm going to leave you with this one here. We did this trial very, 3 years ago, and we were getting the system to classify asbestos that was exposed. Now, if you think about assets in oil and gas that have asbestos lagging in places, if we can start using this in drones or scanning technology and detecting the exposed, not the encapsulated stuff, just stuff that's exposed, it changes it. So I just want to say thank you very much for your time, guys. I hope we didn't bore you to death with that. And as I said, it's no means exhaustive. There's some phenomenal stuff going on out there. And yeah, anyone wants to chat to me or Shang, you've got our details there. Feel free to pick up the phone or drop us an email. But now I think it's time for questions.
Well, thank you very much indeed. That was absolutely fascinating. And I've learned an awful lot throughout it all. But I think possibly for me, the key thing that will stay with me is those polar bears. I think they were extraordinary.
It's always a fun tale, that one.
Yes, exactly. So if anyone has any questions, please do pop them into the Q&A section and we can get going with them. Let's see how we do. So between the two of you, you have something like 20 plus years of experience within this field at the moment. Is that right?
Yep.
That's...
Makes you feel old when you say that. Thanks.
Well, it's between the two of you, though, isn't it? We were talking with Historic England a while ago. Between the five of them, they had nearly 100 years of experience, which was incredible. Impressive. But that's obviously also within their particular specialities too. Please don't be shy with questions, because this is absolutely your opportunity to take advantage of James and Shang being here. And we have our first popping up, which is good. So if BV loss was routinely allowed, how much more business would you get?
For oil and gas onshore, I think it's a major need for things like pipeline monitoring. FlyLogix are doing incredible work with it. That's one of the pilot projects we're doing with gas sensing. They're involved with it. The problem we found is the operators want more information on it on the rig. That's why we're there. But yeah, pipeline monitoring, BVLOS mapping for it. Some of the basic stuff with the NUIs. If you could get out there and have a centralized platform and you're flying out to them, phenomenal amounts of work, I think. It's just that age-old problem that ARPAS has seen with some of the guys we talk about, integration to manned airspace. The challenges we've got at the moment is we're creating hazard corridors. We're shutting down airspace in the North Sea, which is some of the busiest airspace in the world for helicopters. Well, it's the busiest heliport. So yeah, shutting down whole corridors is causing some headaches in places.
Absolutely. What would you say has been your highlight in terms of the inspection of in the oil and gas industry?
Shane, do you want to go first?
Go on.
It's a hard one. All of them are quite unique. I suppose it's to realize that, you know, potentially you're solving problems that someone else hasn't, because the technology just evolves so fast. You might by accident done, you know, or solve a problem that no one else has. And I think that's the most exciting part. And I think we've done that with a lot in confined spaces. But James, with I think you probably have done quite others with the fancy solutions you have as well, wouldn't you?
Mine's going to be quite. It is I was on a platform working, doing tank inspections, and one of the guys got quite badly injured in it. And it was the fact that he was stood there with me going, does this mean I don't need to go in there to do this anymore? I was like, well, we can minimize it. And it was just the realization on their face about how much faster we were getting it done without them stepping foot in it. And it was a job that none of them liked doing. And it was just that we'd taken something that was so dangerous and turned it almost to like sitting there having a cup of tea doing it. That was when it sort of realized the impact this technology could have in the industry was phenomenal.
Yes, absolutely. I do really appreciate the differences this must make to the sort of the health and safety side of things. It's huge. We have another one. Offshore, have you looked at automating landing of the drone onto a ship or platform, or is that still manual from the pilot?
No, we've got systems we've used previously that use almost like a QR launch pad. I've seen some great work with people with self-steadying decks for it. So there's definitely some work out there. But a lot of the vessels we operate on are quite large, so we've not really had that. But I would say the automated landing is pretty routine with some systems now.
I can add on to that as well, is you might want to check with some of the aviation advisors, with the operators as well. They may have specific rules where until you can prove to them that the automated landing is safe, they might require you to land manually, for example. So that's something, yeah, that's something worth checking with the operator. Some of them will quite okay, say, oh, it's, you know, this new DJI, this is fine. Others will be, no, I'm not confident yet. You still need to do it manually.
And it's not just the CA, you got it's actors, Yang saying the operators. I've got one that still now with the M300 things like that wants to still use Falcon 8s because of the 8 props, and you have to work with those operators to make them understand the implications of it, and that the tech's safer than it was, because we do forget we're all live, eat and breathe this industry. There are people in it who pick it up every so often as part of their job that they're not up to date with the latest and greatest, and it's our job to kind of educate them.
Thank you very much for the not the warning, but the sort of the advice there as well. It's very, very useful. For the sensor payloads, what are the unique requirements you're seeing from a drone perspective for oil and gas?
Good Lord, that's a hard one. There's so many, honestly, there's so many. So in optical, there can be everything from what we call your GSD, your pixel, to I've got clients now specifying that your bit coloration has to be 32-bit, which is DSLR cameras. In LiDAR, it very much depends on the operator, what you want. Generally, they'll give you an accuracy tolerance, and then you as a technical person, well, not me anymore, have to figure out what payload to use. And thermal's the same. It's, you look at the task in hand, and that's what we alluded to. You need to understand your equipment you're using, not just the drone, the sensors, if it's going to be fit for task, if it's going to give you what you want, and how you're going to utilize it. The data is only as good as the person on the end of it, because I think I've left out a slide here that just prompted me saying about data is king in the offshore industry. My fault.
Don't worry. Given the amount and variety of hazard types in the offshore world, do you think the drone in a box solution will have a place in the offshore inspection ecosystem?
Definitely.
I think especially in UIs, the normally unmanned installations will be key. And also, I'm also aware that some of the decommissioning projects in the North Sea here, you know, when they're down manned, but they still want to keep an eye on some of the sensors, or have some remote sensors and remote, you know, pressure monitoring stuff. So this is where I think there will be a place for doing the both for offshore.
And it's about managing those risks. It's about a really robust risk assessment, understanding your day-to-day risks that exist because of that platform, and then understand the implications of those ad hoc risks that might be weather, it might be bird species. So it's building up a very, very advanced system that can start feeding the information. It might not be fully autonomous. It might still feed back to an operator on base. He'll go, yeah, you're safe to fly. But I think when you look at the risk of helicopters, getting personnel out, drone in the box solutions start becoming the better solution. They've still got their hazards, but they start becoming better in terms of what you're exposing humans to.
Yes, absolutely. Okay, well, I think that might have been the last question I have here immediately. I'll give everyone a moment or two to ask any final questions, but I think that very neatly ties us into the hour slot that we had sort of previously booked with people. And thank you very much everyone for your time and joining us this afternoon. And thank you most importantly to James and Chung as well for your time in talking to us today, your time preparing for it, and obviously the care and attention that you pay within the industry on a wider basis. It's very much appreciated, and we're delighted to see you here today.
Thank you.
If you have got any questions for James and Chung that you haven't had a chance to ask, please do either contact them directly or do get in touch with me at membership@ARPAS.UK, and I'm always delighted to pass them on to James and Chung as well. Oh, last one from Jennifer. Thanks. Really interesting to hear about what you're doing offshore, something we don't get involved in. That's great. So I think that's it then for today. Thank you very much indeed, and thank you very much to our attendees as well. For colleagues, etc., who haven't necessarily been able to make this afternoon, we will be posting the link to be able to watch it again later on in the afternoon on the website, and I'll email everyone as well who has registered to attend and let them know that too. So in the meantime, I hope you all have a good afternoon and have enjoyed today's session. Thanks very much then. Thank you.
Cheers.
Thank you.